Using the Ti-84 graphing calculator to find limits numerically and graphically. Southwestern College, Professor Maria Olivas. In this video, I will show you how to use the Ti-84 plus CE graphing calculator to find a limit numerically and graphically. We will be finding the following limit. The limit, as x approaches 5, of x squared minus 25, all divided by x minus 5. Let's begin by pressing the y equals button. We're going to input this as a function. Y sub 1 equals, we're going to press alpha first, and then we're going to press the y equals button to go ahead and input this as a fraction. We're going to press the number 1 option for n divided by d, which stands for numerator divided by denominator. And now we will input our function. So that's going to be x squared minus 25. And that's in our numerator. Now we're going to press the down arrow key to go to the denominator, and that's going to be x minus 5. Now we're going to exit this screen, so we're going to go second and quit. And now we're going to go to the table, so we're going to go second and table. Now if we look here at this table, look at the very bottom of the table where x is equal to 5, it says our y sub 1 value here, it says error. This is because our function is undefined at the value x equals 5. If we look at the denominator here, we have x minus 5. If we set our denominator equal to 0 and we solve, we arrive at the value x equal to 5, which tells us that our function is undefined at x equals 5. So this tells us that we cannot substitute the value of 5 into the function to find our limit. We need to approach this in a different way. So another option would be to solve this either numerically or graphically. Let's begin by solving this numerically. So I'm going to come up with a table of values, and I'm going to come up with values that are approaching this function both from the left-hand side and from the right-hand side. And we're going to choose values that are getting very, very close to the value of 5 on both sides. Let's begin by going to second and table set. We're going to change the independent variable here from auto to ask. That way we can choose the values that we want for the independent variable. Let's go second and quit to exit that screen. Now we're going to go second and table, and remember that we cannot choose the number 5, because if we plug in 5, if I press 5 and enter, I get error, because we now know that that value of 5 is undefined. So we are going to go delete for that value, and let's choose values that are very close to 5. Let's choose values that are slightly smaller first, so values approaching 5 from the left-hand side. For example, 4.9. We get 99/10 for our y value, and that value is in fraction form. If we wanted to see it in decimal form, we can go to mode and then go down to where it says answers, and we're going to switch our answers from auto to DEC for decimal answers. Then press enter on DEC. Now go second, quit. Now we're going to go to second table, and now we're going to choose, now you notice that next to 4.9 we get 9.9. Let's choose 4.99 for x. We get 9.99 for y, Let's choose 4.999 and we get 9.999 for y. And lastly, let's choose 4.9999 and we get 9.9999. These values seem to be approaching 10. But just to be on the safe side, let's also choose values that are slightly larger than 5, or values approaching from the right-hand side, like 5.1. We get 10.1. Let's choose 5.01. We get 10.01. Let's choose 5.001. We get 10.001. And let's also choose 5.0001. Now here it gives me the value of 10 for that y value, but that is not the actual value. There just isn't enough decimal spaces here to give me the actual answer. So here I have zoomed into the table so we could focus on this value. What I'm going to do is I'm just going to go ahead and move the cursor. I'm going to move it up and over one space to the right from where it was at so that it lands right on top of the 10 under that y value. And if you look below, it says y sub 1 equals 10.0001, which is the actual y value. It just doesn't appear on the table because there isn't enough spaces for it. What I'm going to do is I'm just going to go ahead and write it in on my own so that it appears. I have removed the calculator portion and we're just going to focus on the table. Next to the 5.0001, I am going to write in the 10.0001 for that y value that is associated with that x value. Now let's focus in on these y values and see which number it is getting closer and closer to. As we approach 5 from the left-hand side, our y values are getting closer and closer to the number 10. And as we approach 5 from the right-hand side, our y values are getting closer and closer to the number 10. Therefore, the limit as x approaches 5 of this function is going to be equal to 10. This is how you would find a limit numerically, by using a table of values. Now let's go ahead and find the limit graphically. In order to do this, we are going to press the trace button. The trace button is at the top of your graphing calculator right next to the graph button. Once you press the trace button, it takes you to a screen that shows you a graph of the function. So the graph appears to be a line with a y-intercept at 0, 5 and a slope of 1. And if we press the right arrow key, we see different x and y values for points on this line. If I press 5.001, this types in the value for the x value, and it automatically gives me the y value, which is equal to 10.0001. So this is another way that you could also find values that are on your graph. Let's press zoom, and I'm going to press on number 4 where it says z decimal. This will show us a coordinate plane where the x-axis extends from -6 to 6 by a scale of 1 and the y-axis extends from -4 to 4 by a scale of 1. We're going to press window and we're going to change the x-min value to 0. It currently says -6.6 after I press that z decimal. So let's change that to a 0. And then let's press the down arrow key. The x max is at 6.6. I'm going to leave it at that. The x scales at 1. The y min is at -4.1. Why don't we change that? Let's change it to 0. No, on second thought, let's change the y min to a -1. And the y max, let's change that to an 11. Here we proceed to a graph of our function that's focused on quadrant 1, our x-axis extends from 0 to 6 with the tick mark separated by a scale of 1, and the y-axis extends from -1 to 11 with the tick mark separated by a scale of 1. As we move our cursor closer and closer to x equal to 5, here I am at x equal to 4.75, y is equal to 9.75, and if I move it over again another spot, I'm at x is equal to 4.8, y is equal to 9.8. It appears the more I move it to the right, I'm getting closer and closer to y equal to 10. Here x is equal to 4.9, y is equal to 9.9. As I move my cursor to the right, this demonstrates how I am approaching x equal to 5 from the left-hand side. If I move it over one more space, x is going to be equal to 4.95, y is going to be equal to 9.95. Once again, I'm getting very, very close to y equal to 10. If I move it over one more spot, it says x is equal to 5, y is equal to, and there is nothing there. And that is because at x equal to 5, the function is undefined. So therefore, there is no value for y. And if you look very closely at the graph, you can actually see that it does appear to be a gap right where x is equal to 5. Like it just jumps, the line just jumps from one spot to the next. There's like a hole, and that actually does represent a hole in our graph. If I move over again to the right hand side, I would land at x is equal to 5.05, y is equal to 10.05. And if we move one more spot over here, we've got x is equal to 5.1 and y is equal to 10.1. And then we've got, and so forth. So you can see that the numbers coming in from the right hand side from x is equal to 5, they are approaching 10 as well. So even when we are approaching 5 from the right hand side, we are still approaching that value of y equal to 10. So this is how we can tell that if we find the limit graphically, the limit as x approaches 5 of this function is still going to be equal to 10.